Hello. Where am I? I'm not in the picture at the moment, but I'll come into the picture. I'll find out where I am by specifying coordinates in space. I guess that's a way to locate position of where you are, where a point is in space. In analytic geometry, often the association is the point in space is associated with Cartesian coordinates. So you specify an x and a y. And you locate where you are by going out a horizontal distance x and up a vertical distance y. What we're seeing last time was that there is an alternate way of locating a point in space. Instead, you can specify where you are by giving an angle theta and a distance r. Those are called polar coordinates. Well, polar coordinates are just as valid a way of specifying a location in the plane as Cartesian coordinates. R and theta are as useful as x and y for doing that. Now, in an algebra course, you're often interested in graphing a function by linking the variables x and y. What you end up graphing is y equals f of x. And treating x as the independent variable, y as the dependent variable, the points that satisfy that equation often form a curve in the plane, and that's useful for understanding what the rule is associating y's and x's. We're going to do the same trick today where the variables relevant are not going to be x and y. Instead, the variables are going to be r and theta. Variables r and theta will work for finding equations. We will typically take theta to play the role of the x. Theta will be the independent variable, and we'd like to see how r varies as a function of theta. When we find that out, we'll have a different looking family of curves in the plane. Ones that come out typically might not be the kinds of shapes you've seen before. These are called polar coordinates, and we're going to be working with a polar function grapher.